Hello everyone, and welcome back. So we're still answering that question of really what is an engineer? What can you see? What do engineers do? They do a whole lot, honestly. We're going to hit more on what the engineers do today. And I want to correct one thing that was in my last video. When I said you can become a professional by being my class, I meant that more in the figurative sense. There actually are professional engineers. Just like doctors get the MD after their name, and a doctor in front of it. Or DDS for a dentist, you have to pass certain exams to become a professional engineer. Anyone can call themselves an engineer, but if you want to be a professional one, you actually have to take an exam. And not everybody does that. Not many people do. I have not. I never took the exam. So I'm not technically a professional engineer. I could become one. I just haven't taken the time. So you are going to become a professional on the fact that you will know how to do the engineering profession. You know how to become an engineer. You'll know how to think like an engineer through this class. Okay, with that, let's look at what kinds of engineers are there. So there's a lot of them. Literally, if you look in like Indeed.com and you type in engineer, you'll see thousands of different types. I put it with a broad brush here, and there's lots of different like mini kind of like specializations that'll go inside of these. Okay, so mechanical. The first and most common job is in HVAC. So heating and air conditioning. Really, that's where a lot of mechanical engineers go. They do this a lot with not just like in your home, not talking about that kind of system, but with large industrial factories which need massive amounts of cooling, mechanical engineer. Or with the internet. There are these servers somewhere hidden throughout the world that house the internet. And those things are hot. Those servers are extremely hot. They give a lot of heat off. And so understanding how that heat is moving through the servers, through the towers, and through the room allows you to control that heat and hopefully remove it effectively. Cars, quite obviously, they're mechanical machines, and so we are controlling them a lot. You see a lot of mechanical engineers who are working to improve cars, to make them more efficient. Working on engines, working on new designs for wheels, different things like that. Robots, mechanical engineers don't typically build the motors and sensors that allows the robot to see and to feel and to think and move. They build the body. They're more like the skeleton, okay? So somebody else builds the muscles, you build the skeleton that it goes on and making sure that it's strong enough to withstand what's going to be happening. And all sorts of mechanical devices. Like, so if you bend something, break something, any type of tool, mechanical engineering. Okay, civil engineers. They're sort of the kick your tire engineer. If you can walk on it, stand on it, if it's not supposed to really move and it's huge, it was probably a civil engineer. This includes bridges, buildings, roads, any large structure will have a civil engineer. That is their purview. They are very, very good at it. Not saying that mechanical engineers won't be helping. They will. These are always going to be seeing a range of engineers. If I had to pick a point person for a building, it would be a civil engineer. Okay, electrical. Think robots again, but this time the muscles, this time the brain. Somewhat brain. You might have a computer scientist in there as well. But the muscles, definitely. They would be the ones attaching all those sensors, all those motors that allows that robot to move. They're also in power generation. So think solar panels, think those wind farms, okay? Those are all going to be in the electrical engineering field. So if you like renewables, electrical engineering is probably for you. Okay, materials. I like to always say that if I was to go back in time, blacksmiths were materials engineers. You just don't realize this. When they're smacking with the hammer, they have that anvil and they smack the piece of metal with some hammer. What they are doing is changing the properties of that piece of metal. And in doing that, they're making it stronger. And that's all about what materials engineering is. They are trying their best to make new materials or find ways of processing current materials to make them better at what they have to do. Examples of this would be Kevlar or plastics or different metal alloys. There are so many metal alloys. There's like infinite amount of metal alloys. And they range from stainless steel to chrome, just whatever you want. A materials engineer is working on that. They're the ones who could tell you if you have the right material for what you're trying to do. Environmental engineers. Once again, renewable energy. They're very big in that. And also conservation efforts, trying to make sure that we are taking care of the environment, that we're not polluting, that we're using things as efficiently as possible. Think resources here. They're trying to make sure we use our resources as efficiently as possible. Okay, computer engineers, I'll be super honest. Like the definition by a lot of places for a computer engineer is someone who's building microchips and processors. However, some universities will also say that a computer engineer is someone who's making software. That's kind of a weird thing. So if you want to be a guy making software, like I love to code, it's so cool, this is all me, JavaScript every day. I like to code. If you want to talk about that, email me. Then you probably want to be like a software engineer or a computer scientist. Computer engineering, though, might still be for you. Like NC State, you get they definitely connect coding with building the computer, putting it both together, which is a good thing. You have a broader brush. And then finally, there is industrial engineering. So industrial engineers are all about factories. But if you're thinking, I'm going to be walking around a factory every day of my life, yes, that's awesome. It's actually not that. You do go to the factory, you will definitely be walking around, you'll be meeting people, shaking hands. Probably not anymore. But the big thing for them is understanding, will this factory run if random person gets sick? Because you can't just rely on everybody staying healthy or not taking a vacation day forever. So eventually someone's going to do that. You have to be able to move people around to have enough extra help that when that one person's sick, everything doesn't fall apart. There needs to be redundancy. Also machines, they're going to break eventually. How often do they break? Well, how often they break depends on how many extra you will need. And so they're doing a lot of computational modeling and determining the best way to make your factory run efficiently. Another thing you might not think about is ergonomics, making sure that things are comfortable and easy to use. Because it doesn't matter if it's the most amazing tool ever. If it's painful or just doesn't feel right, nobody's going to want to use it. Nobody's going to want to use it. So with that, that kind of sums up what different kinds of engineers you can see. There's plenty more. The book has several others I didn't even go over. But these are the big ones that typically people ask me about. So I put them in this PowerPoint. And always, if you have questions, if there's anything else that you want me to cover, please email me. I would be happy to add more videos. See you later.